Do you get me? So there is an old record. There is a claim. So your claim must always show the parameter of interest. So this is the parameter of interest. In this question, they didn't say. So every time, okay, when you look at the problem, you must know what is the parameter of interest. Okay, in this particular chapter, we have only two parameters of interest that we are going to study. One is the mean weight. The other one is the proportion, population proportion. Okay, that is under the other part, under the proportion. So bear in mind, we have only two parameters of interest. Yeah, there are many others parameter of interest. You can talk about the standard deviation of the population. You can talk about the median of the population. But here we focus on two only. You get me? Okay, so now, so how are we going to prove this? We know that. Okay. So what he did is, Rick's friends argue that this does not prove that the average, this is the, okay, sorry. 5.2 is a sample mean. Sorry, 5.2 is the sample mean. Okay, still remember how to write sample mean? Amanda, you still remember how to write sample mean? This is called sample mean. Okay, sorry. The weight is W, correct? So I write W bar. That means this is the mean of one of the sample. So I can take many samples, and each sample I can find the mean. So can I just based on this sample mean and conclude that this one is more than 5? Can I?
No.
Why not?
Because the sample is not big enough. No.
Is it the sample not big enough?
The range of samples is not big enough.
What do you mean? The range of the sample is not big enough? Okay, can someone please talk? So that will answer our part A. Can you give me, does Rick's sample prove that the new mean weight of his pumpkin is exactly 5.2? That means you are talking about, that means you have the sample mean, one of the sample mean weight. Is equal to 5.2 kg. So can I use this to make a conclusion that therefore the population mean weight is also 5.2? Can I make that conclusion? Is this true or false? Select. Avika, is this true or false? Everyone have to talk, please. Avika, true or false?
False.
Okay, why?
Because the sample mean weight does not necessarily mean that the actual weight is also the same weight.
Okay, so what you can say is, thank you. What you can say is that the mean weight of a sample doesn't represent the population mean, because each sample can give us a different mean. Correct? That is how you should put it. So you have to write in words. So the answer here is false. So you cannot just base on one sample mean, just based on one sample mean to make a conclusion about the population mean. So that is how you answer part. Does Rick's sample prove that the new mean weight of his pumpkin is exactly 5.2? We cannot use one sample mean, a sample mean, to make a conclusion about the population mean, because each sample may give us a different mean. Some may be more than the population mean, some may be less than the population mean weight of the pumpkin. So the answer for part A is no, and you have to know how to explain why. Are you okay? Now, for part B. Okay, in what range of values is it likely that a new mean weight of pumpkin lies? Xin-Chi or Xin-Ren? Can you answer this question?
4.5 to 5.5.
Huh?
4.5 to 5.5.
4.5 to 5.5. How you know 4.5 to 5.5?
Because the standard deviation is 0.5.
Because the standard deviation, where on earth they tell you the standard deviation is 0.5, that is the old standard deviation. Okay. Maybe. Okay, so you see, Xin-Ren, I don't know whether it's Xin-Ren or Xin-Chi, you are trying to say, because the old population mean is 5 kg, and the standard deviation is 0.5 kg. Okay, so Xin-Ren judge that, okay, the new, this is the new population mean will between 5.5 kg and 4.5 kg. Yeah, possible. But is this the correct judgment? You just based on the old data. How about the new one? So that means that is a good judgment, nothing wrong. So we are going to know how to judge. We are going to know how to judge, okay, by looking at, okay, so this part, yeah, this is a very rough judgment. So we are going to learn how to make a judgment by talking about, in this chapter 9b, (9c), and after that we go to 9b. So how to make a judgment on, based on one sample mean, how am I going to make a prediction of the population mean? So this one, all this will study at this part. If anyone, based on whatever you have learned, you say the mean weight of the population. Okay, actually, look, actually from here, correct? We can only judge the weight of the pumpkin. We can judge the weight of the pumpkin. Whatever your judgment here is the weight of the pumpkin. One standard deviation away. Okay, you are not judging this. But at least it gives you a rough idea. You see or not? So now if we want to judge the mean weight of the pumpkin, so we have to know what is 9B, 9C, 9D pretty well. Do you get me? So I'm not going to go fast. I'm just trying to give you some idea. So far, so good? Any further question? So if you just base your understanding, then you can just make a judgment like that. That means if you judge the mean weight of the pumpkins produced using a new farm technique as 5.5, that means you are assuming every pumpkin produced is 5.5. Okay, now, got it? Okay. C, let's go to part C. Does it matter whether Rick choose a test to test a small sample or a large sample? In this case, does Rick tell us that how many pumpkin he takes from his farm to find the average? He doesn't, correct? He just said take a sample. He just said take a sample. So that means here, he doesn't tell us the sample size. Sample size is a question mark. Sample size, that means how many you take. How many pumpkins do you take? So sample size always put as n. How many? 10, 20, 30. So will the sample size affect? Okay, does the sample size, does it matter whether Rick choose a test, a small sample size or a large sample size of pumpkin? Does it matter? Does it matter? Siti?
Yes.
Okay, how it affect?
Because if like use more sample, maybe have more variation of the weight of the pumpkin.
Okay, the answer is a yes. Because if you take a smaller sample, what do you mean by the variation? What sort of variation are you talking about?
I mean like more different weight for each pumpkin.
What do you mean by more variation? Okay, for example, this is all the pumpkin I produce. Then I take this pumpkin, 2, 3. Okay, each pumpkin, the weight is 4.2, 4.1, 4.2. Do you think they got a lot of variation? compared to, I take from the population, I take 5 pumpkin. This is 4.2. This is 5.1. This is 5.5. This is 3.2. This is 4. Which one have higher variation?
The second one.
The second one. So this one, the N is 5. This one, the N is 3. So which one will have a better variation? Which one will have a higher variation? So it does matter. So you cannot use the word variation. You get me? So what can you say? If you use a bigger sample size, what does that mean? If possible, I will take the whole, all the pumpkin produced by this farm, correct? But is it possible to take? And I use this technique, it got different season. Can I not, can I cover the whole population? Can I cover the entire thing? No. So if you increase the sample size, what does it tell you? What does it tell you about the relationship between the sample and the population? Like for example, you look, okay, I have a class of 30, that is my population. Okay, I put my samples as 2 students only. So I pick. So I pick the one with the highest and the one with the lowest. I find the average. So does that give a good representation of the mean mark of my class?
No.
No, it doesn't. Or I take 2 with the highest. But if I take 5 students, will it give a better representation?
Yes.
Yeah. So the sample size does affect the result. The bigger the sample size, it gives a better picture of the population. So that's why there is some criteria that you must take certain sample size. So later we will study in 9B, 9C. And there is a theorem for us to follow. If you don't want to follow the theorem, you come up with your own theorem and make sure it is true. This theorem, people have proved it already. So when you talk about statistics, right, you want to use your own idea, go ahead. Whether people accept it or not, that is up to them. So we are going to use some theorem, some theory that people have found out and people have proved it is true and it is recognized by everyone. Got it? So when you talk about statistics, it's not you say as you like. No. You cannot just based on one number and say everything. You have to go into the theorem why you do this, why you do that. So we know that now sample size does affect the result. The bigger the sample size, that means the more individual I take from the sample, I take from the population to represent the sample, that means it will give a better representation. The bigger the sample size, it gives a better representation of the population. Okay? So I answer part C. You don't have to worry about here. I just give you a rough idea. Okay, now part D. Part D. How can we establish the likelihood of whether Rick's claim is correct? That's what we are going to talk about in 9D. That's what we talk about in 9D. That is talking about confidence interval. How are we going to establish? We are going to establish that using a theorem called central limit theorem. Hello? Any question? Anything that you like to say? Yeah, nice here. You have to develop part by part. So you better listen to everything carefully. I tell you, if not, your 28% will be gone. I'm telling you, 28%. The weightage is very, very high. You not only have to listen to what I say, you have to read, please. Okay, so we read the next part. Consider the following question regarding the mean and the population of the mean and proportion of a population. That's why I say our parameter of interest for this one is the population mean and population proportion. Proportion will be part of the whole thing. Yeah, so you based on that, our parameter of interest for any problem is we want to make prediction of population mean based on a sample mean. How we predict, I will teach you later. Or we are interested in population proportion. Okay, when you say proportion, you will give in percentage. Like for example, population proportion is 92%, that kind of thing. Based on a sample proportion. And how do we write sample proportion? P with a hat on top. So your sample proportion or your sample mean, we call it the point estimator. Point estimator. Did I spell it correctly? Wrong. MATOR, point estimator. These are the things your book doesn't give you, okay? I read point estimator. So this parameter of interest, okay? So consider the following question regarding the mean and the proportion of the population. So your parameter of interest, what is the average height of Australian adult female? So your parameter of interest is you want to know the average height of Australian female. Okay, what proportion of Queenslander have visited the Northern Territory? So that is the parameter of interest is the population proportion of Queenslander that have visited the Northern Territory. So if you want to find this, so you have to do sampling. Okay, so now I ask you why sampling. So can anyone now, you got your handphone, you can Google why sampling. You answer this question, why sampling? Okay, I give you 5 minutes to think. So one reason is because the population is too big, you take too long to study the whole population. Yeah. Okay, some more. Save money, save time. Some more. What do you mean by save money, save time? Okay. So you have to explain in detail by yourself. Okay, now what is the goal of sampling? The goal. You know why sampling area? Goal of sampling. So you cannot say to represent. If you say goal of sampling is to represent the population, then how are you going to get it?
The goals of sampling are to use a procedure that is likely to yield a representative sample of the population as a whole.
This one you read from Google, is it?
Yes.
So I'm going to give you a one which is I find that is very good one. Goal of getting. Okay, so I write a new one. The goal of getting sampling statistic. We call it sampling statistic. Statistic is to accurately, listen, accurately, not precisely, Accurately, that means I try to get as close as possible, but not precisely. Accurately reflect a population parameter. So in all our discussion, our population parameter will be these two. Why sampling? You know. What is the goal of sampling? You also know. So since we are talking about collecting a sample, collecting samples, so what are we going, how should we collect a sample? So now, how? Okay, can someone answer how to collect samples? Safan? How should we collect a sample?
I think randomly pick any randomly pick.
Okay, that means first of all, you have to must collect random sample. So what do you mean by random samples? Can someone Google and tell me what do you mean by random sample?
Samples chosen at random.
Hey, you are not explaining what is random sample. Yes? A part, let me read, let me read your answer. Everyone in the population have an equal chance to be selected as part of the sample. A part of a sampling technique in which each sample has an equal probability of being chosen. Yeah, that is right. Okay. Got it? So that is called a random sample. Every individual in the sample, in the population, has an equal chance to be selected from as part of the samples. So can I have the same reading? Can I pick the same pumpkin again for the case? Like for example, I select 10 pumpkin from a basket. Okay, I want to. So the keyword is equal chance to be selected. Okay, so if I have okay, I got 10 bucket of pumpkin. Okay, so I pour all the pumpkin in. So I pick one. Then I record down the weight. So should I put that particular pumpkin back into the container before I select the next one?
Yes.
You have to. So can I, is there a chance that I will select the same pumpkin again? The answer is a yes. So that is called everyone in the population has an equal chance to be selected as part of the sample. So that is called random sample. So my question now is, if you have followed the technique, okay, how to select a sample, you say random sample, you have collected a random sample. Will this random sample, the value, represent the parameter of interest that you are talking about? Will this? We know from the beginning of the opening problem, correct? Definitely no, correct? Definitely no. So which means that a well-selected, when I say well-selected sample means random sample, okay? A well-selected sample, okay, that means my random sample I select it properly, okay? I don't do it simply. Will still not produce a statistic that matches the parameter exactly. It will naturally, this is nature, naturally be off a little from, it will be off a little from the parameter. So the parameter, you have to look at your situation that you are talking about, of interest. So what do we call this? We call this as sampling variation. So that means each sample will give me a different, even how well I select, I won't get exactly the same. Can I get two that is the same? Possible, but I won't get everyone the same. So that is called sampling variation, and which means that you will come to it, we call it sample standard deviation. So sampling variation, we call it, is the natural occurrence difference between a sample statistic and a population statistic. So when I say population statistic, that means I'm talking about the parameter of interest that I have. That is population mean or population's proportion. Okay. So I want you to go back and find out this part. Bias sample. What do you mean by bias samples? Okay. So we got all this right, then we will talk about the rest of the thing. Then that will be a much better idea instead of throw you with straight away with central limit theorem and so on. Okay, if you got time, read more. So please, what do you mean by bias sample?
Samples that are not picked
Oh,
by.
no, don't give me straight away.
Oh, okay.
I don't think you have to read more. You have to read more. Yep. I read a lot. And all this, whatever I discussed today, whatever I discussed today, please bear in mind, you are going to use it when you write your folio. You are going to know how to start and how to bring the whole thing in. I'm teaching this chapter based on my idea of how to start your folio and how to bring all the concept that we learn in. Okay, because your folio, you need to write 15 pages. Later, when come to folio, I will go through with you, tell you the skeleton, how we are going to plan and do the thing, so that we can use whatever we have in our class time to complete whatever we can. So don't say Max take up your free time. I never.